Alright class, today we're going to talk about properties of functions. We're going to spend 2 days on this. First thing I want to talk about is what is an absolute max and min. Absolute means it is the lowest point of the whole function, and absolute max means it's the highest point. For example, on this diagram here, this would be the absolute min, because it's the lowest it goes. Now, would you guys say there is an absolute max? Hopefully you said no, because it goes on forever up in the up direction, so there's no absolute max. Here there's an absolute max, but not an absolute min. Okay, so that's what absolute means. Relative means it has a little peak or valley. So if we look back at the first drawing again, I'll do this in blue. A relative max would be like this little hump here. This would be a relative max. And a relative min would be this dot here. It's not the lowest, but it is a relative. Now we list all of the maxes and mins as relative, and then we have to figure out which one the max and mins are, the absolute one is then. So now we're going to talk about increasing and decreasing intervals. It's basically the x values that the function increases or decreases over from left to right. And this is where we use interval notation again. Alright, so let's take a quick look at these types of problems. So if you guys need to keep writing this, just pause the screen because I'm going to keep going. It says list all the increasing and decreasing intervals for these problems. So let's take a look at this. From here to here, you guys would agree that that's increasing until it gets to that point. From -3 to -1, you would probably say it's decreasing. From -1 to 2, you would say it's increasing. From 2 to 4, you would say it's decreasing. And from 4 to infinity, it's increasing. So I'm going to say for my increasing intervals, the function is increasing from -infinity all the way up to -3. Again, we're only looking at x values. And for these, we're not really going to ever use the brackets because we don't really want to say it's increasing or decreasing at a point. Now, to connect your different intervals in interval notation, we're going to use a union. Then we would say the next time it increases is when x is -1 to x is 2. And then we look, and sure enough, there's one more spot where the function increases, and it's from 4 all the way to infinity. Decreasing are the opposites, so it would be -3 to -1. Again, we're looking at only x values for interval notation, and 2 to 4. So that would be the increasing and decreasing intervals. So over here, increasing, decreasing, increasing, decreasing. Again, we're going from left to right. So increasing, we'd say again -infinity, and it looks like this x value is -2. And again, if you guys think you know how to do this, why don't you pause your screen and try to do it on your own before I finish. You could always do that with these videos. Union 0 to 1. Because there's the x value of 0, there's the x value of 1. It's increasing between those two x values. Decreasing, we have, looks like it starts at -2 and goes to 0. And it starts at 1 and goes to infinity. So those are your increasing and decreasing intervals. Okay, now we are going to put everything we've learned together and work on doing increasing, decreasing, and all the mins and maxes. So here's the diagram we're going to put together. And it says local maximums. So basically you're looking for the local high points. So if you notice, this is a local maximum at -8, and it looks like 4. So these are just coordinates now. These are not intervals. This would be 0, 6. And this would be 9, 10. So those are all the tops of the graphs. Local mins, so where the lowest points happen. Oh, actually, no, we're okay. You also need to test endpoints, but if you notice, both of these endpoints are local mins. So we actually have a couple local mins. We have here, 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 and that's a min as well. So I have negative 10, 0. I have negative 4, negative 3. I have, what do I have? 3 comma negative 2. And I have 15 comma 0. And if you notice, if I would have said what's the absolute minimum this function has, you would say it's a value of negative 3 when x is negative 4. That's the lowest one. All right, increasing intervals, up, up, up. So those 3. So I'd say it starts at negative 10 and goes to negative 8. And now that we're doing intervals and not points, we have to use unions. Negative 4 to 0. Remember, we're looking at only x values, not y values for intervals. And finally, we have 3 to 9. Decreasing are the opposite ways, so these 3 intervals. So we would say x is negative 8 to negative 4. Union 0 to 3. Again, we're only looking at x values. And then 9 to 15. X-intercepts are where it hits the graph. There are a lot of x-intercepts for this graph. 1, 2, 3, 4, 5, 6. So we have the point negative 10, 0, negative 7, 0, negative 1, 0. Oops, too many negatives there. 1, 0, 5, 0, and 15, 0. The y-intercept for the graph, there's only one usually for a function. That'd be 0, 6. Okay, so that's kind of all the information you should know how to do with a function. List the points that are max and mins, list the intervals where it's increasing and decreasing, and then tell me the intercepts. Even symmetry means it has y-axis symmetry. It also means that if you input a negative x into the function, you should get out the same thing as if you put x into it. Odd symmetry has origin symmetry, which means that if you put a negative x into the function, you should get out a negative value for that function. Now, we're not going to do anything with that today. That's how you do it algebraically. We'll do that tomorrow. For today, really just know the two symmetries. So, if we look at this graph right here, you would agree that this thing is folded over the y-axis, so this has even, this is an even function. This does not have y-axis symmetry, and it doesn't have origin symmetry. Origin symmetry would do that. Be in quadrant 3, not this. We don't have any definition for x-axis symmetry, otherwise we would have that there. So this would actually be a neither. And finally, this is a cubic function. This one displays origin symmetry, because if I put 1, 1 in, if I put negative 1 in, I'll get a negative 1 out. So that's what this is saying here. If I decide to change 1 to negative 1, then the y will also change to negative 1. So this is an odd function. Okay, so one more thing to kind of just demonstrate these things. We're going to graph it so it's even and odd from what it was started at here, this piece of function. So in even, I'll do in blue. Even's the easy one. You keep the y's the same but switch the x's. So when x is negative 3, it's 5. So when x is 3, it's 5. Negative 4, 3, 4, 3. Negative 6, 3, 6, 3. And then when you connect the dots, it should look like it was folded over the y-axis for an even function. Okay? For odd, you switch both signs. So we had negative 3, 5 should now be at 3, negative 5. So when I make the opposite of x, I get the opposite of y. Negative 4, 3 is 4, negative 3. And negative 6, 3 is 6, negative 3. So this should look like this. So if you just look at the red and the black, that is what origin symmetry is, which gives you your odd function. All right? That is properties of functions dealing with intervals, increasing, decreasing, mins, maxes, and even and odd. We will continue this tomorrow.